functions. Mathematical relationships are one thing, but they may or may not be a function. So when we say identify functions, we want to determine if a function is a relation of functions. So there's always mathematical relations. I can take numbers, I can add them, I can subtract them, I can multiply them, and I can have rules that help me take an input and do some math on it and then spit out an output. Okay? But functions are a special group of relations that we like to take an interest in math, because there's a lot of rules and a lot of things we could do. And so one way to identify a function is through mapping. So if I have the values -3, 0, and 4, and those values are mapped to -2, 1, and 7. Now here's the interesting thing. -3 is mapped to -2. 0 is mapped to 7. And 4 is mapped to 1, right? This is a function. Okay? Now, I'm going to do another set of numbers. Okay? Two is mapped to 3. 2 is also mapped to 7. 3 is mapped to -4, and 1 is mapped to 7. Actually, let me do this last part over. Let's just leave it like that for now. Based on the mappings, one of those is a function and one of them is not a function.
Nice jam.
Yep. Can somebody tell me why the second one is not a function? Christian.
It's because 2 goes to two different numbers.
Mm-hmm. X corresponds to 2 y values. Okay? Where in the first one, x responds to a unique y value. So here we would say x maps, responds isn't probably the right word. Maybe we should change this word to maps. But x maps to 1 unique y value. That's it. That's how you can tell if something's a function if you're looking at the mapping. Okay? Now, another way that we could do this is in example 4. So before I go to the example 4, are there any questions? No? All right. Can I move on? Yep. All right. So that was example 3. Example 4, sometimes you'll have a graph like this, and you'll have a mathematical relationship like that. This has x and y values. Okay? And if I do what we call a vertical line test, we can see that this is not a function. And this has a lot to do with example number 3. And the reason I say that is right here, I have an x value, right? Let's assume that x is equal to some number a. That means that right here I would have a and some corresponding y value, but we'll use function notation, which is f of a, which is like x comma y. And down here, I have another value of a, and then a different value. So I would say a sub 1, actually it's the same a. So this would be like two different numbers. So now I'm going to plug in some numbers just for the fun of it. Let's say this is -2, comma 3, and this is -2, comma -3. Just for the fun of it. Now if I were to make my mapping, I have -2, and that corresponds to both 3 and -3. So if I base it on what we just did in example number 3, what would you say occurs when you draw a vertical line? If it crosses twice, it's not a function, and how does that relate to the mapping?
Well, okay, so yeah, like how you said, when it crosses twice, that means like one x value is equal to two y values.
Perfect. He said one x value can equal to two different y values. You can have two outputs for one input. Does that make sense?
Yep.
All right, let's see if let's test your understanding of this. Ready? Okay. Is that a function or not a function?
Function.
How?
Because it only maps to
One x for one y.
Yeah.
Yeah, one unique output per input. If I draw my vertical line here, only crosses once. Draw it here, crosses once. Draw it here, crosses once. Here, crosses once. Here. So we have one unique output, which we'll call y, per input, which we will call what? That make sense?
Yep.